So here they're saying that f of x equals to this one. So first of all, before going to this, we'll learn some things. So for any just a moment, actually. For any unconstrained optimization, any optimization problem will be consisting of these components: objective function, decision variables, minimization problem, and constraints. Okay, so objective function, decision variables, minimization variables, and minimization, I can say it as minimization problem, then variables, constant. These are the four components of any optimization problems. There are four kind of optimization problems. One is linear problem, there is non-linear problem. In linear problem, how you can say that it is a linear problem is nothing but objective function, and next 1 minute. Objective function, and whenever constraints are linear, I can say that the problem is linear problem. Okay, when either of the objective function and continuous constraints are non-linear, then I will be saying it as non-linear problem. So in non-linear problem, there are two types of problem. One is convex problem, another is non-convex problem. In linear problem, we have different types of problems, like integer problem, integer linear problem, and binary linear problem. Next is the quadratic linear problem. Mixed integer linear problem. Okay. So here integer linear problem is nothing but it's also a linear problem, means it is a linear problem first. It will be having the objective function and the constraints as linear, and the interval, suppose if I am considering x1, f of x1, x2, then I can say x1 will be having a set of integer values and x2 also will be belonging to set of integer values. It will not belonging to all the other values, but only integer values will be considered. Then I can say this particular problem as integer linear problem, and binary linear problem is x1 and will be belonging to only two values, that is 0 and 1, and x2 will also belonging to 0 and 1. And quadratic linear problem is it is linear problem where you will be having x1 with the quadratic values, quadratic equations. Mixed integer means it will be having integer values and also real values also. Okay, so these are different kind of problems. So for unconstrained optimization or univariant optimization, I need to determine, I can either say that it is maximum or minimum value, means it is having maximum f of x and minimum f of x value. Next, now in univariant optimization, optimization problem. I have this function called minimum f of x belongs to R. So this is a univariant optimization problem. So f of x is called as objective function and x is called as decision variable. And I can say that this is minimum. So what are the necessary conditions for this optimization problem to minimize this? First of all, there are two respective conditions. First necessary condition is f of f derivative of x, okay? Derivative of x equals to 0. This is the first necessary condition. Second necessary condition is f double dash of x, that is double derivative of f of x, should be less than 0. See, so these are the two necessary conditions. So they are asking in our question, so here they are asking, this is our equation, f of x equals to 3x power 4 minus 2x cube minus 3x square plus 6. Then the first order necessary condition for either maximum or minimum of f of x is. Okay, let's write the equation and we'll try to solve it. So f of x equals to 3x power 4 minus 2x cube minus 6x plus 6, I think so. Let's see. Yeah, minus 3x square. Sorry, it's on 6x. Minus 3x square plus 6. Plus 6x, I think so. 3x power 4 minus 2x cube minus 3x square plus 6. So first I need to find the first order necessary condition will be f derivative of x equals to 0. So how can I calculate the derivative of this one is, let's suppose I have this f of x equals to a into x power n. So f dash of x as a derivative of this function will be equals to a into n into x power n minus 1. Okay. So if I have x power n, then I can say n into x power n minus 1 will be the derivative of this. So similarly, I will try to find the derivative of this one. This is a power x power 4. So here 3 into x power 4, right? 4 into x cube minus 2 into 3 into x square minus 3 into 2 into x power 1. As this is a constant, it will be 0. So let's calculate this one. So here I will be having 12x cube minus 6x square minus 6x equals to 0. So this will be my first order necessary condition for the either maxima or minima of f of x. Okay. So this will be your answer. That is 1B will be your answer. Okay. So next they are asking us for this function, which of the following points are stationary points of f of x? Okay. So from this equation, how can you find the stationary points? First of all, I'll try to minimize this function. Simplify this function. Sorry, this equation. I'm taking 6 common. Then I'll be getting minus x equals to 0. Okay, this is my equation of the simplifying. Now what should I do? I need to find the stationary points, right? I need to find the stationary points. So how can I find the stationary points of this? First of all, I need to find the roots of this equation. So how can I find the roots of this equation is, I will take x common here. So once I take x common, I will be getting 2x square minus x minus 1 equals to 0. From this, I can say that x equals to 0. And this, I'll be getting 2x square minus x minus 1 equals to 0. So already I got one point here, that is x equals to 0. Now I need to find the roots of this equation. So if you have any equation of this form, ax square plus bx plus c equals to 0, then how can I find the roots of this quadratic equation is minus b plus or minus square root of b square minus 4ac by 4a, I mean 2a. This is your way of finding the quadratic equation. So if I compare this one and this one, I'm able to see a equals to 2, b equals to minus 1 and c equals to minus 1. Okay, I'll substitute them here. So minus b, so it is minus 1, right? So here I'll be having minus 1 plus or minus square root of b square is 1, 1 minus 4 into a is 2 and c is minus 1 by 2 into 2. Okay. So I'll be getting 1 plus or minus square root of 1 plus 8 by 4. So this will be equals to 1 plus or minus square root of 9 by 4. This will be equals to 1 plus or minus 3 by 4. From this, I'll be getting 2 equals to x equals to 1 minus 4, 1 minus 3 by 4. That is, again, I'll be getting 1 plus 3 by 4. So this will imply that x equals to minus 1 by 2 comma 1. So x equals to 0, minus 1 by 2 comma 1. These are nothing but the stationary points. Okay. In this way, you can find the stationary points from by finding the first derivative and equating it to 0. You can find the stationary points. Okay. Now, the other way is that what you can do is you can first calculate the derivative of this f of x and substitute these values. These are 4 options, any of these 4 options, and for which you are getting f dash of x equals to 0. Then I can say those points will be considered as stationary points. Till here, is it clear? Any doubts? Till here you understood, guys, how to find the derivative and what are the stationary points? Please respond.
Yes, ma'am.
Okay.
Yes, ma'am.
Now let's go to the third question. So like that, once you have solved the stationary points, you can see that minus 1 by 2, 0 and 1 will be the stationary points. You can directly substitute 0 in f dash of x. This is your f dash of x, right? So once you substitute 0, I'll be getting here 0 value, f dash of x will be 0. Like that, if I substitute 1 also, it will be 12 minus 6, that is also 0. Similarly, if I substitute minus 1 by 2, I will be getting minus 3 plus 3, that time also it will be 0. That's why these 3 values will be my stationary points. So now they're saying for this function, the stationary points which maximizes the value of f of x. So from the set of stationary points, if you have to find which of these stationary points is maximizing or minimizing f of x or minimizing f of x, the necessary means what is the condition for this will be is for maximizing it will be f double dash of x is less than 0, and for minimizing the condition will be f double dash of x greater than 0. Okay, I will explain you with one example, then you'll understand. So the equation for us is this one. So we got it as 12x cube minus 3x square, right? 6x square minus 6x, right? This is our f of x, f dash of x. Now I need to calculate the derivative of this again. So then it will be f double dash of x equals to 12 into 3 into x square minus 6 into 2 into x minus 6. So once I calculate, I'll be getting 36x square minus 12x minus 6. Okay. So now, what are stationary points? Our stationary points are 0, minus 1 by 2, comma 1. Okay. So first of all, I am trying to find, they asked us, so for which of these stationary points will be maximizing the value of f of x. So what is the necessary condition for f of x? The necessary condition for for maximizing f of x is nothing but f double dash of x must be less than 0, right? So we need to calculate for each of the stationary points. We need to find out. We need to substitute these values in the double derivative, in the second derivative of this one, and let's see whether we are getting the positive value or negative value. If you're getting the negative value, then you have to consider that particular stationary point, because the necessary condition for this will be f double dash of x is less than 0. Okay, so I'm substituting here 0 minus 0 minus 6. So I got it as minus 6 is less than 0. So this should be one of the points which is maximizing the f of x. Okay. Now let's check the other points. If we substitute f double dash of 1, 36 into 1 minus 12 minus 6. So we got it as 36 minus 18. 18. This is a positive number, so we should not consider this point for finding the maximum of f of x. Okay. Similarly, you need to calculate f double dash of minus 1 by 2. That will also give you the positive number only. 36 into 1 by 4 minus 6. 12 by plus 12 by 2 minus 6. So this will give you 9 plus 6 minus 6. Again, it's a positive number, so I should not consider this point. Only 0 is a stationary point. The stationary point 0 will be the one which will be maximizing the f of x. Okay, that's why 0 will be the answer. So next they are saying us, for the function f of x 3x power 4 minus 2x cube minus 3x squared plus 6, the stationary points which minimize the value of f of x is. So we need to find what is the necessary condition for this. The necessary condition for this, for finding the minimum of f of x, will be f double dash of x is greater than 0. This will be your necessary condition. Okay. So we already substituted the values of stationary points in second derivative, right? 0 will not give you the minimum, minimum function of f of x. You already got the values where f double dash of 1 and f double dash of minus half minus 1 by 2 is greater than 0. Then these 2 points will be considered as minimum points. Okay. I mean, these stationary points will be used for finding the minimum values of minus 1 by 2 and 1. In that way, you have to find. Just remember the shortcut for this. If you remember, if you have to find minimum, f double dash of x is greater than 0. Opposite of this you will be finding. Okay. If I have to find maximum, I just do the reverse of this one. F double dash of x is less than 0. First order condition will be first derivative of x equals to 0. From this, if you want to calculate stationary points, you will find the roots of the equation. Like that, you will be getting the stationary points. Once we got the stationary points, which of those stationary points can give us maximum and minimum of f of x, that is used to f of x, that is you can do that by finding the second derivative of f of x. Okay, that's how you can solve these problems. So if the objective function, inequality constraints and equality constraints are all linear functions, the type of optimization problem is linear problem. I already told you that whenever objective function and constraints are linear, it means that the problem you are referring to will also be linear. Okay. And next here, for any 2 points x1 and x2 in the range and 0 less than lambda less than 1, f of x is a convex function, then this is the theorem, guys. It's already proved. So this will be your first one. It's already inbuilt theorem. You can just check online. I'll share you the link. You can check that as a proof. Okay. Now they're saying consider an optimization function f of x. If x is a decision variable and f is a function to be minimized, then the type of optimization problem is, so here only single variable is there and f is a function to be minimized. So it is like this, in this way it is written. This is the function what we are discussing here. Did I write it? So this is the function what they have done. One decision variable is there, minimum function is there, f of x. Now what do you call that is? The optimization problem will be considered as unconstrained optimization. There is no constraint defined, right? That's why it is called as unconstrained optimization. So these are your assignment answers. That's it. That is how you can solve the problems in week 4. Any doubts still here? Is it clear? So guys, what you will do now is you have some problems in week assignment, practice assignment. You need to do that practice assignment. Let me just open it. So please do this practice assignment, guys. Do the problems 2 and 3 and give me the answers. Do the problem 2 and 3 and give me the answers, guys. It is in a practice assignment. So you can check the second question and third question and give me the answers. What will be the answers for second and third? Is it clear what you need to do? Come on, give me the answers for second and third, guys. You need to solve these according to the way I told you now and give me the answer. Okay, you gave me the answer for 2D. What about third one? Everyone please do the second and third one. What about others? No one is replying. Only Vinod replied. Guys, why no one is replying? So how do you solve third question? How do you solve the third question? What is the approach? I already explained it. They are saying that you have to, for a function f of x, the same function, which of the following value stationary point? So first you have to calculate the derivative of this one f of x. Okay. Once I calculate the derivative of f of x, I will be getting the equation as 20x cube minus 90x squared plus 80x. That should be equals to 0, and that particular f dash of x should be equals to 0, and I need to substitute one of these values. So 0 will definitely be one of the stationary points. Then it will be 3.28 also. Okay. Next, fourth option is the maximization of a function is equal to dash of the function. The maximization of function will be always equal to minimization of the function. Okay, that is the answer. For this function, which of the following are stationary points and minimizers? Can anyone please solve this one? You have to calculate the stationary points, and out of the stationary points, you also need to know the minimizer, which is the minimizer. So what will be the condition for minimizer? You have to calculate second derivative of this one, and you have to see which of the, whenever you substituted the stationary points, for which values of stationary points you are getting the second derivative of this one as greater than 0, then you can conclude that these are nothing but your stationary points and minimizers. Okay, please solve that and tell me the answer, guys. Now I need the answers now. Yes, Vinod, very good. So please solve the answers. Solve this problem and let me know. Guys, whoever is not responding, I don't know you are listening to the class or not, but you have to take this subject very seriously. Your seniors are having many backlogs in this subject. If you don't prepare this seriously, no one can help you out. So please take this seriously and prepare. 2, 0, and minus 1. Okay. Any other answers? Do we have that question? And some more problems I'll give you guys. So like this also you might get the questions. Sorry, I'm not able to share my screen. You please do the practice assignment also and submit that assignment. You will get to know like how much you understood. Okay, very good. 2 and -1 are the answers. Let me present my entire screen. There are some more problems where you can solve them. And just go to the course one. This is not the one which I need to do. I need to go to the previous course. So how many problems you do, those many problems, I mean, you can gain confidence on that topic. So let's check this one. So like this, they will be asking us some of the core problems if you see. Different types of optimization problems are based on like the components what I told you, constraints, objective function, decision variable. So these are the different types of optimization problems which will be based on these three components. Okay, you also have minimization problem, but they didn't give that, so you have to opt constraints, objective function, and decision variables. So here the class of optimization problems where the decision variables takes a value of either 0 or 1, and I already told you binary integer programming problem that is called as this one. Okay. Now, can you please answer this question? If f of x is x power 4 minus 3x cube plus 3x, 3 square plus 10, then the first order necessary condition maximum or minimum of f of x is. This is the question answer. Right? Not this one, sorry. Just close this one. Yeah. This is the question, fifth question. Please answer me the fifth question. What will be the option? The first order necessary condition for either maximum or minimum of f of x is. So give me the answer, guys. So what will be the option answer for fifth one? Very good, guys, is A. Right. So you need to find the first derivative of this one. So it will be 4x cube minus 6x square plus 2x equals to 0. Okay. Now for this, for the function f of x equals to x power 4 minus 3x cube plus x square plus 10, which of the following will be stationary point of f of x? Please calculate this one. We need to calculate the stationary points of f of x. Very good, guys. Yes. So first of all, what will I do? I will calculate the derivative of f of x. Okay. So it will be 4x cube minus 9x square plus 2x equals to 0. Then I'll be substituting the values of this. Means I need to actually find the roots of that, or else I can do the back substitution. Then I'll be getting 0 to 1 by 4 as the answer. Very good, guys. So for the function, this one, the stationary point which qualifies to maximize the value of f of x. So how can we calculate that? I already told you what will be the necessary condition to check one of the stationary points to maximize the value of f of x is you need to calculate the second derivative of f of x, and second derivative of f of x should be less than 0. Whenever you substitute any of the stationary points, then those stationary points will be constant. So out of these three stationary points, so which stationary point qualifies to maximize the value? Please find the second derivative and substitute those values and see for which values you are getting the second derivative which is lesser than 0 value, negative value, you need to consider those stationary points. Tell me now. Yes, guys, very good. It's 1 by 4. Okay. So from here, I'll be getting 4x cube minus 9x square is 2x. So again, I'm twice square. So this is your equation. You find out. So our equations. So x power 4 minus 3x cube plus 6 square plus 10, right? So first I'll be finding f dash of x. Okay, so it will be 4x cube minus 9x square plus 2x. Okay. So once I find, then again I need to find the second derivative of this one. So it will be 12x square minus 18x plus 2. Okay. So we already got the stationary points here. Those stationary points are, so I need to equate it to 0 and find it. Okay. So by x will be 0, that will be one of the stationary points. So once I take x common, so I'll be getting 4x square minus 9x plus 2.
Ma'am, you're not sharing your entire screen.
Okay, wait. Just, I forgot about I shade tab. Now is it visible? Okay.
No, ma'am.
Not. I shade it, no? Okay, just a moment, wait. It's visible, no, ma? Okay, wait. Okay, so getting shared, just a moment. Yeah, so I was saying about this one. X bar 4 minus 3x cube plus x square plus 10. So the first order of f dash of x, I found it out. Okay. From here, if you equate it to 0, you will be getting the stationary points. So x equals to 0 will be one of the stationary points. And now this is the other equation. 4x square minus 9x plus 2 equals to 0. Okay. Now you can calculate, now you can find the roots of this equation by equating it to this formula. It will be minus b plus or minus square root of b square minus 4ac by 2a. Using this you can do, or else you can do back substitution. So once we have done the back substitution, let's check what are the values given here. The stationary points 0 to 1 by 4, right? So we have this 4x square minus 9x plus 2 equals to 0. We need to substitute with 4. If I substitute with 4, I'll be getting 4 into 64 minus 9 into 4, 36 plus 2. Sorry, here 16, right? 16 for 64 minus 36 plus 2. But we are not getting 0. Wait a minute, somewhere I think I have gone wrong. 1 by 4, it is not 2. Okay. The options they have given here is 4x square minus 9x plus 2 equals to 0. So we need to first of all find f dash of x. X, we are considering 0 to 1 by 4 these values, whether we are checking whether these can be the stationary points. So first of all, f dash of 0 will be 0 only. So it is one of the stationary point. Then f dash of 2, we are finding 2 into 4 into 4, 16, 9 into 2 plus 2. It is 18 minus 8 is 0. Yes, this is one of the stationary points. Next, we need to find f dash of 1 by 4. So it will be 4 into 1 by 16 minus 9 by 4 plus 2. So I'll be getting as 1 by 4 minus 9 by 4 plus 2. Once I solve this, I'll be getting as minus 8 plus 8, so it will be 0 only. So these three will be your stationary points. Now they are saying which of the following values, which of the stationary points will be trying to maximize the value of f of x. So you need to find f double the second derivative, and in the second derivative you have to substitute all the stationary points. This is my second derivative. Okay, so I am writing f double dash of 0. Once I substitute 0, I will be getting 2 is greater than 0, but they're asking us to find the maximize, where they're saying us to maximize the value of f of x. So the condition will be f double dash of x is less than 0. Let's see by substituting f double dash of 2. So I'll be getting 2 into 4 minus 36 plus 2. Again, it will be 48 minus 36 plus 2. Again, it will be a positive number. So this also will be omitted. Next, we are checking f double dash of 1 by 4. We need to substitute in this equation. 12 into 1 by 4 whole square minus 18 by 4 plus 2. Whole by 16 minus 18.4 plus 2. So here it will be 16. So you need to get 12 minus 30, 18 fourths, right? 18 fourths is 72 plus 16. So you'll be getting a negative number. So obviously this will be less than 0. So this is the stationary point for which you are getting the maximum value of f of x, which is nothing but the maximizer. So in this way you need to find the values. Okay. So let's say for the function, the stationary point which qualify to minimize the value of f of x. Minimum for minimizing the f of x, the necessary condition is f double dash of x is greater than 0. This is the condition for minimizing the f of x. F double dash of x is greater than 0. So here you can, we already got for 0 and 2, we got the positive values, right? So these positive values you need to consider. So 0 and 2 will be the stationary points which are minimizing the f of x. Okay, like that. Like that you need to find out. Okay. Any doubts? Is it clear, guys? I hope week 4 is clear to you all.
Yes, ma'am.
Okay.